Hello everyone, welcome to My Math Teacher. In this video, I am going to solve question number 5 from the exercise 1.5. This is for class 9 students from NCERT syllabus. The chapter is number system. Question here is rationalize the denominators of the following. We have 4 subdivision under this. What is rationalizing? Rationalizing is simply removing this radical sign which is present in the denominator. Now why we have to do this? So because we have to rewrite this fraction where this irrational number which is present in the denominator becomes rational number. So why we have to change from irrational to rational? Because it helps us to solve the problem quite easily. So for example, let us take this rational number root 5 divided by 2. So as we know, root 5 is 2.2360. It goes on like this. Now when we divide it by 2, we know we can easily divide it. So it will be 1.118. It goes on like this. So it's very simple to find out the answer, which is 1.118, etc. Now the same question. So let us change it the other way. That is, if it is 2 by root 5. What will be the division? So it will be 2 divided by 2.23606, etc. Okay. Now as you can see, this is irrational number, non-terminating and non-repeating. So this is the rational number. Now dividing 2 with this irrational number will be quite tedious. So that's the reason we are bringing this denominator from irrational to rational. Given subdivision is 1 by root 7. As you can see, this is a monomial. There is root 7. So first of all, what we have to do is we have to change root 7 to 7, which means what we are going to do is we are going to multiply by root 7. As you can see, root 7 is present. To make it 7, we can multiply by root 7 into root 7. So simply we can't multiply by root 7. So to make it equal, so what we are going to do is we are going to multiply and divide by root 7. As you can see, we can divide root 7 by root 7, which gives us the value as 1. So the root 7 into 1 will be again the same root 7. So the value remain unchanged. So first of all, first step is write multiply 1 by root 7 into root 7 by root 7. As you can see, we are multiplying and dividing by the same denominator. So here, when you divide it, the value will be 1. So 1 into the entire fraction is the same value. The value will never change. So now, just multiply the numerator and numerator. So 1 into root 7 is root 7 divided by 7. So this is the answer. As we can see, from irrational, we have changed it to rational number. This is called rationalizing. The second subdivision is 1 by root 7 minus root 6. As you can see, this is binomial. So root 7 minus root 6. Instead of this, the pattern is different. So in this case, what we have to do? So we have to use algebraic identities. First step, multiply and divide by its conjugate. So I'll explain what. Now in this case, you have to observe here carefully. So the denominator is what we have to focus now. Root 7 is taken as a minus root 6 as b. That is a minus b. So we need to change this into a rational number. So in this case, we are going to find a minus b into a plus b will give us a square minus b square. So when you square it, the radical sign will be removed. So now here, what is this? This is called as conjugate. Conjugate is nothing but the same numerals with the opposite sign. So if it is minus here, the conjugate is plus. If it is plus here, the conjugate will be minus. So what is the conjugate now? The same numerals with the opposite sign. That is root 7 plus root 6 divided by root 7 plus root 6. Now multiply numerator into numerator. So 1 into entire root 7 plus root 6 will be the same values, root 7 plus root 6 divided by. So now as you can see, a minus b into a plus b, that is a square minus b square. A is root 7 square minus root 6 square, which is root 7 plus root 6 numerator as it is, divided by root 7 square is 7 minus root 6 square is 6. As we know, root 7 into root 7 is 7 only. Okay. Now finally we have got root 7 plus root 6, just simplify, divided by 7 minus 6 is 1, which means the same value, root 7 plus root 6 divided by 1 is the same answer. So therefore we can say that 1 by rationalizing 1 by root 7 minus root 6 is equal to root 7 plus root 6. The denominator has become 1. From the irrational number, we have changed the denominator as rational number, which is 1. Third subdivision here is 1 by root 5 plus root 2. As you can see, this is binomial. Again the same procedure, multiply and divide by its conjugate. So 1 by root 5 plus root 2, which is a plus b. So we have to get a square minus b square, which means we have to multiply by a plus b multiplied by a minus b will give us a square minus b square. So what is the conjugate? This simple logic. This same numerals with the opposite sign. So root 5 minus root 2 divided by root 5 minus root 2. Okay. So this is called as the conjugate. 1 into any number is same number, that is root 5 minus root 2 divided by. So a plus b into a minus b is a square minus b square. So a here is root 5 square it minus b here is root 2 square it, which is equal to root 5 minus root 2 divided by root 5 square is 5 minus 2, which is root 5 minus root 2 divided by root 5 minus root 2 divided by 3. So from irrational, this irrational denominator we have changed to rational denominator. The same way we will solve the last subdivision, that is 1 by root 7 minus 2. So we have to again the same procedure, multiply and divide by its conjugate. So what is the conjugate? The same numerals with the opposite sign, that is a minus b will be multiplied by a plus b, which gives us a square minus b square. This square will remove the radical sign. So a plus b, what is this? Root 7 plus 2 divided by root 7 plus 2, which is numerator into numerator. 1 into any number is the same number, that is 7, root 7 plus 2 divided by square it. Root 7 is a square minus b square is 2 square. Okay. Now here it is root 7 plus 2 divided by root 7 square is 7 minus, what is 2 square? 4, which is equal to root 7 plus 2 divided by 3. So from irrational we have changed into rational. See you in the next video. Until then, take care. Bye. Keep practicing.